Welcome back to ETCS Bites Back. And rather than continuing chapter 5, I decided to include a session on shifted locations, and that was in response to a request by a commenter on one of the earlier videos. So what are shifted locations all about? Well, ETCS has a location reference system, and that is used for track information, movement authorities, train position reports, anything where there needs to be agreement between the ETCS onboard and trackside about the location or extent of something. And the origin of the reference system is the last suitable Belize group that the onboard has read, and that's often called the last relevant Belize group, LRBG. So how's that used? Well, when we send a position report from an onboard, it contains the identity of that LRBG, the distance the front of the train is estimated to have travelled from that LRBG, the direction relative to the LRBG that the distance refers to, which way the train is facing relative to the LRBG orientation, and the way in which the train is travelling relative to the LRBG. In most cases, this is quite a simple set, but it can become more complicated, particularly where a train reverses having passed over an LRBG. This information is contained in the position report and is used by both the onboard and the RBC. Each Belize group, comprising of more than one Belize, has an orientation. If there's only one Belize in the group, then the orientation is assigned by the RBC, and that's the subject of a different video. So if we have our Belize group, it has, in this case, two Belize's. One is identity 0, the other identity 1. And the identity 0 is known as the reference Belize. And it is from that Belize that all the distances are measured. So let's imagine we have a train. Our train has passed over the Belize group some time ago and is proceeding towards the right. It will be able to report an estimated distance from that 0 Belize to the front of the train. And it will also report that that distance is in the nominal direction relative to the Belize group, nominal being 0, 1, 2, 3, and the reverse would be 3, 2, 1, 0. So the train is now reporting that it has gone a certain distance in the nominal direction relative to the Belize group, and the RBC can then reconcile that with its map of the railway. The train will also report its orientation, in which case means which end is the leading and active cab. In this case, that is also in the direction of the LRBG, so its orientation is also nominal. And it will report its direction of travel. In this case, it's going forwards, it's going away from the Belize group, and it's continuing in the nominal direction. And all these items get reported as part of the position report. And we can see that the various items in the position report come from the information we have just been looking at regarding this train. So what happens when a train gets a movement authority? Well, that movement authority is related to the Belize group, the LRBG, and again, it starts at the reference Belize. And the applicable direction of the movement authority is either nominal or reverse. In this case, it would be a nominal direction movement authority relative to the 0 Belize in the LRBG. So let's now think about when a train turns round. It previously has gone from left to right, passing over the LRBG in the direction 0, 1. But now it has stopped, the driver's got out, moved to the other end, and it's ready to proceed back from right to left. The train will work out an estimated distance from 0 Belize to the new front of the train. And that distance will still be in nominal distance from the Belize group. Although the train has turned round, the distance is measured in the nominal direction from that Belize group. However, the orientation will now be reported as reverse because the train is now travelling and organised in the reverse direction relative to the Belize group. The leading cab is now on the left-hand end. And similarly, the direction of travel will be reverse because it is going from right to left. And that will be reported in the position report sent as part of start to mission. The distance to the LRBG will have been reduced by the length of the train because the front of the train is now at the left-hand end rather than the right-hand end. But we've now got a problem because any movement authority sent to a train has to be orientated on the LRBJ. The LRBG in this case is in front of where the train is. So the movement authority, which will be set with the QD direction flag set to reverse, will go to the left of the police group. We now have a real problem because the train has no movement authority to get to that police group. But in level 2 or 3, we actually want the RBC to be able to send the information. So how are we going to achieve this? Well, we're going to achieve it by looking at using a shifted location. And the shifted location is effectively moving the origin of the movement authority and all other information sent by the RBC. So we still have an estimated distance from the zero belize to the front of the train. And we also have the known length of the train. So what we can do is send a message to the train saying that the movement authority and other information contained in that message is offset, and it's offset by a distance called dref. And that would typically be the distance to the LRBG from the front of the train plus the length of the train. So the movement authority that we would have had starting at 0 belize can now start at our new origin. And the first section of that movement authority would be increased by the dref distance. So the train now has a movement authority starting at the rear of the train and enabling the driver to move forward, pass over the LRBG again, this time in the reverse direction, and report a new position and subsequently get movement authority updates. But what would happen if we had gone over the LRBG in the reverse direction? So hence QD LRBG is reverse. Well, the dref is again typically the distance to the front of the train from the LRBG plus the length of the train. However, in this case, because the QD LRBG is reverse, the dref is sent as a negative distance. The distance is always positive in the nominal direction of the police group. dref is about the only variable which can be used in ETCS which can be both negative and positive. So when the movement authority is created, the L section is reduced by dref since QDLRBG is reverse. And of course, two negatives make a positive. So effectively, the movement authority gets extended to the back of the train again. So how's this all done? Well, it's done by sending either a message 3, the movement authority, or message 33, the movement authority with shifted location. This is only available when the message is sent from the RBC. It doesn't apply in level 1. The movement authority message 3 contains the packet 15, the movement authority, and other optional packets. And it also references the NID LRBG. Message 33, which is the movement authority with shifted location, also has the same content. However, additionally, it has the dref distance, which can be both positive and negative, and a scaling factor for that reference distance, Q scale. Other than that, the two messages are the same. However, the effect for the train is different. So hopefully that explains how a shifted location works.